Hello everyone and welcome to the series Mastering Maven. With this series, we will dive into the world of Apache Maven, a powerful tool that simplifies your project management like magic. Whether you are just starting on your coding journey or you are a seasoned professional looking to streamline your workflow, these videos have something for everyone. We will break down the basics, showcase advanced features, and explore best practices to elevate your development game. We will start with absolute basics. What is Maven? Why is it so popular? How it works and how can you use it to build your applications in the most efficient way? So grab your favorite beverage and let's get started. What is Apache Maven, you ask? Apache Maven, or in short just Maven, is popular for its build capabilities. That is why most people refer to Maven as a build automation tool, or in short just a build tool. Yet Maven is not just a build tool, but it is more than that. The project team responsible for the development and maintenance of Maven describes Maven as a software project management and comprehension tool. Based on the concept of a project object model, Maven can manage a project's build, reporting, and documentation from a central piece of information. Do remember this term project object model, or in short POM, because you will hear and use it all the time when talking about Maven. We will discuss POM in great detail in our later videos. So as you can see, Maven aims to be more than just a build automation tool. But you might ask, what do we mean by more than a build tool? Well, apart from providing the build capabilities, which comprise of pre-processing, wherein you initialize your build, which could mean setting up environment variables, processing some configuration files for the build, copying files if you need, and then compilation, where you take the actual source code and compile to ensure there are no errors in your code. Then you test the code by running the automation test, be it unit tests or integration tests, and once your code is tested, you package your code, wherein you will be creating a jar file or a zip file or a Docker image or whatever your packaging need is. And finally you distribute it, so you would be publishing to your company's repository of artifacts or deploy the packaged artifact on a server. But apart from all of this, the build tooling, Maven can do things like generating reports. These reports could be a unit test report, or you have a tool that does some performance testing for your application. Maven can take the performance test data and generate a report and publish them. You can also generate a documentation website from Maven. People who are familiar with Java docs, Maven provides support for generation of Java docs, which is a very common documentation format for Java source code. What else? You can also use it to communicate within your team. Maven can act as a team member and can send you notifications on your Slack or Hangouts or any other messenger. And it can do a lot more things. All applications built today have dependencies. This XKCD diagram depicts the nature of modern day applications and their interdependence. As much as using dependencies allows us to quickly build the applications, dependency management becomes an important thing. One of the biggest benefits or features that Maven brings with it is the dependency management. If you have ever worked with Apache Ant, you will know how much things got better when you started using Maven. A typical Java application these days has multiple dependencies. For example, here I have an application which has two dependencies. A web server that is going to handle requests, could be Tomcat or Jetty or any other web server, and I have a database driver that allows me to connect to a database. Without Maven, I will need to download the jar files from the internet, copy them to the library folder, and then add these to the application class path. Now when I run the application, after compilation and building, the application works. That's a lot of manual work. Now instead of manually managing these dependencies, I can configure these dependencies in Maven and let Maven do all the hard work. Maven will download the jar files from the internet, use them for compiling, testing, and then package it along with the final packaged artifact. You might think these are just two files and I can manage that. But these days, typical Java application has easily more than 10 dependencies or jar files. If you start managing these dependencies manually, trust me, it is going to be a nightmare. In fact, let me give you an example how managing dependencies manually can easily go out of control. So taking the previous example, we have Web Server 1.0 and DB Driver 1.0 in the application. The application is running fine and there are no issues. Consider there is a critical security bug reported for Web Server 1.0, and this happens all the time. Developers managing Web Server fix the security bug and release a new version. This new version is Web Server 2.0. Since we do not want the security bug to affect our application, we will need to update the web server dependency from 1.0 to 2.0. So we will download the latest web server 2.0 jar file and add it to the application. But when we try to run the application, it fails. Why? Because in a hurry, to fix the security bug, web server 2.0 became incompatible with the DB driver 1.0. Developers of the DB driver, on realizing this, fixes their compatibility issues and releases the new version for DB driver, which is version 2.0. So now what we will have to do now? Again the same process. Update DB driver to version 2.0, we download the app jar file, add it to the application, and then the application starts to run again. This is a very simple example with just 2 dependencies. Manual dependency management gets really complicated once you start to deal with dependencies over 10. Worse, you update a single dependency and you see multiple other dependencies becoming incompatible with each other. There is a cascading update of dependencies required until all incompatibilities are resolved to eventually have the application working fine. This is where Maven Dependency Management comes into picture and the power of Maven. How will Maven help here? We will configure both web server and DB driver dependencies in Maven configuration file. Whenever we update any of the dependencies, all related compatible dependencies are also fetched by Maven. In our example, when we update web server 2.0 in the Maven configuration file, Maven automatically fetches the compatible DB driver 2.0, and all this happens magically under the hood. All you do is update that Maven configuration file and Maven does the magic for you. But you might wonder, how does Maven does all this magic? The answer to that question is plugins. Maven makes use of plugins. Whatever activity you can think of, there is a plugin for that activity. You want to compile your source code? There is a plugin to compile your code. You want to run tests that you wrote in the application? There is a plugin for testing. You want to create a Docker image so that you can deploy your application? There is a plugin to build a Docker image. In fact, there is even a plugin to create the Maven project structure called Archetype. It allows you to create your starting project structure, the folders for source code, folders for test cases, and then create the Maven configuration file so that you can adjust the settings as per your need. Whatever Maven does, it does it with the help of plugins. These plugins contain the code to perform the activity. Maven just triggers the plugin code as per your user needs via the Maven configuration file. Maven works on all 3 platforms, Windows, Mac and Linux, and you will need Java to run Maven on your system. In fact, we will see the installation of Maven in different systems in our future videos. And this is a very brief introduction to Apache Maven.